Hello friends, here in this video we are going to study the basic rules for the design of RCC column as per IS standards 456/2000. Some of the points which we are going to cover in this video is what is column, classification of column, reinforcement in column, effective length of column, minimum eccentricity in column, detailed rules in the column as per IS standard. Column, basically a vertical compression member which may be subjected with the axial load considered as column. Here the effective length of column exceed 3 times its lateral dimension, that is given in the third point. L effective should be greater or equal to 3 times of lateral dimension. If the effective length of the column is less than the 3 times lateral dimension, then it is known as a pedestal. The compression member which is included or a horizontal and it's subjected with the axial load is considered as thrust. Here the columns are classified based on their shape, material of construction, type of loading, slenderness of column, type of the lateral reinforcement. Let's first see shape of a column. There are basically 6 cross-sectional shapes which are being considered. First is square section, rectangular section, circular section, L section, T section and plus section. Next, classification based on material of construction. Columns are made up of different materials. Some of them are timber column, masonry column, PCC column, RCC column, steel column and composite column. Further, they are further classified based on the loading. First type of loading is axial loading column. Basically, column is subjected with the axial load passing through the centroid of the column is to be considered as axial loaded column with zero eccentricity and no bending will be generated. And second type of the loading is eccentrically loaded column. The column is subjected with the axial load, do not act as on central axis of the column. Then the eccentricity will be in the both direction. Bending will generate in the both direction. As both types of loading are being shown in this figure. First, axial compressive is a proper loading, axial loading, and remaining two loading are the eccentric loading. Further classification is done on slenderness of column. First we will see short column, in which effective length divided by dimension should be less than equal to 12. If we consider square or rectangular cross section, width will be value of B, and if we consider circular cross section, D will be the diameter. And for the slender column, as shown in the image, L effective divided by B will be greater than 12, or L effective divided by D will be greater than 12. It will be considered as the slender column. Here we are looking the difference between the short column and the long column. Basically, L effective divided by B is less than equal to 12, or L effective by D less than equal to 12 is considered as the short column, and long column is considered when L effective by B is greater than 12 or L effective by D is greater than 12. Basically, in the short column the load carrying is high as compared to the long column of the same cross-sectional area. And in the long column, the load carrying capacity of the long column is less as compared to the short column for the same cross-sectional area. For the short column, the failure of the short column is by crushing, and for the long column is generally by buckling. Here we are going to see the type of reinforcement. There are basically two types of reinforcement provided in RCC: longitudinal reinforcement and transverse reinforcement. It is also known as a lateral reinforcement. Here, lateral reinforcement are basically two types: wind loaded and earthquake loaded. Here we can see that the wind loaded load is applied uniformly throughout the length, while on the other hand, earthquake loads are applied ununiformly, as we can see in the image. Now we are going to see the effective length of column. The effective length of the column is defined as the length of the column which take the part in a buckling under the action of load. This is also defined as length between the point of contraflexure. It is the unsupported length of column or a clear length or height of the two successive floor. Here we can see that the effective length for different cross sections are given in the column number 2, for name as a degree of the end strain of a compressive member, then the theoretical values and recommended values. Mainly for the calculations we consider theoretical values, and we are going to cover that. If we consider both the end fixed, then the length is to be taken as L by 2. If the both ends are pin joint, it should be taken as L. If one of the end is fixed and the other end is free, then the theoretical value will be twice of L. And one end is fixed and one end is pin, then it should be taken as 0.7 into length. Now we are going to see minimum eccentricity in column. Minimum eccentricity is can be defined as all the columns shall be designed for minimum eccentricity equal to the unsupported length of column 500 plus lateral dimension or 30, subjected to the minimum of 20 mm. Where biaxial bending is considered, it is sufficient to ensure that the eccentricity exceeded the minimum about one axis at a time. Here there are some rules in a column as per IS 456/2000. Let's see the main reinforcement rules. First, the cross-section area of the longitudinal reinforcement shall not be less than 0.8 and shall not be more than 6% of the gross section area of the column. Next point, minimum number of longitudinal bars shall be 4 in the rectangular column and 6 in the circular column. Third point, the bar shall not be less than the 12 mm in diameter. Spacing of the longitudinal bar along with the periphery should not exceed 300 mm. Next rules are: for the lateral ties pitch, the lateral dimension of the compression member 16 times the diameter of the longitudinal bar, 300 mm diameter of the bars, 1/4 diameter of the largest longitudinal bar, 6 mm, or whichever is more. Thank you friends to watching this video. Subscribe this channel and like this video and share this video. Thank you.